Welcome to 4 week on Engineering Economics 2373. And what we're going to see here today or this week is we start to put together these concepts to evaluate projects. We're going to see different methodologies, and we're going to do some numerical examples to understand these methodologies. So the first thing that we need to know is the 7 steps technique for system economic analysis, and they are very common sense. The first one is to identify the investment alternatives. The first step. The second step is define the planning horizon. Sometimes two different alternatives may have different planning horizons, and we need to compromise which will be the planning horizon we are intended to use in our evaluation methodology. Number 3 is to specify the discount rate, and that is the time value of money that we want to use for purposes of the economic evaluation. Number 4 is to estimate the cash flows, and that is a time-consuming process to estimate and make forecasts on what the cash flows in the future will be. Number 5 is to compare the alternatives using different performance measures, and we're going to talk about those performance measures. Number 6 is to perform supplementary analysis that will allow us to make sure that the decisions we're making are sound and robust. And finally, the step number 7 is to select the preferred investment. The 10 principles in engineering economic analysis has to do with what we need to take into consideration before we go into making this type of analysis. First and foremost is money has time value. And that's the essence of what we've been seeing in this course. Second principle is we need to make investments that are economically justified. Principle number 3 is we have to choose among mutually exclusive investments alternatives in such a way that it maximizes our economic worth. Number 4, out of two investment alternatives are equivalent if they have the same economic worth. Number 5, the marginal revenue must exceed the marginal cost in the alternative. Number 6, continue to invest as long as each additional increment of investment yields a return that is greater than the investor's time value of money. Number 7, consider only differences in cash flows among investment alternatives. And we're going to see a couple of examples on how to do that. Compare investment alternatives over a common period of time, and that's why we need to select the planning horizon. Number 9 is risk and returns tend to be positively correlated. And number 10, past costs are irrelevant in engineering economic analysis unless they impact the future cost. Additional non-financial criteria that needs to be taken into consideration include quality, safety, environmental impact, capital requirements, and political and social costs. So essentially, project economic valuation is include the formulation, estimation, and valuation of economic outcomes while the alternatives for the achievement of the objectives are available. It is founded on a collection of mathematical techniques that simplify the economic comparison. The preferred performance measures are present worth, annual worth, and future worth, and we're going to see that all these 3 are equivalent. We have the internal rate of return, external rate of return, savings investment ratio, payback period, and perpetuities. Before we continue, let's define what's a minimum attractive rate of return. The minimum attractive or minimum acceptable rate of return is the rate that we will use to discount our projects as the time value of money that would be considered by the investors in the project. It is somehow related to the financial cost for the investor, and taking into consideration that a project can be financed by means of debt or capital or a combination of both. So let's understand these concepts. Let's consider two projects. Project A with cash flows being from 0 to 4, and t equals 0 to 4. Cash flows are 1,000 first, and then for years 1 through 4, 400. And for project B, we'll have an initial investment of $2,000, and then in years 1, 2, 3, 700, and on the fourth period, $1,500. Let's assume that the time value of money for both is 10%. That is, the minimum attractive rate of return that we're going to use is going to be used for both projects, and we consider that this time value of money is 10%. So we can discount each one of these cash flows by dividing 1 plus that interest rate raised to the t, each one of these cash flows. And the summation of this column we have done in the past would be, this is what we have as the present worth of the project. So right now the present worth of project A is 267.95. Let's see what's the present worth for project B. Again, we do this cash flow divided by 1 plus the interest rate raised to the t. And when we add each one of these cash flows, we compute the present worth, and the present worth would be 765 for project B. So if project A and B would be mutually exclusive alternatives, it would be better to invest in project B simply because our total worth would be 765 compared to $267 larger. That is, if we compare the benefit of selecting B over A, the difference is $497. So making that decision, we would get $497 more just by selecting B. These two projects have the same time value money, that is 10%, and then the interpretation of the present worth could be stated as this. If we decide to invest $1,000 and on project A, at the end of 4 years we would be equivalent to $267 wealthier, or our worth would be $260 larger than what we are right now in present dollar terms. In the same fashion, if we decide to invest in project B $2,000, then we would get back our $2,000 and the equivalent to $765 today. We can also compute the annual worth of this project, and for that we use formula PMT equals, we use the rate is 10% and the number of periods is 4 and the present value is 267.95, and that yields 84.53, and we can compute that in the same way. The annual worth for the other project, project B, is 241.44. And finally, the future worth of this project A is future worth rate 10%, number of periods 4, and the payment is 84.53. And similarly, the future worth for project B would be 1,120.50. Now, if you compare the ratio of these quantities for project B with respect to project A, all of these quantities, the present worth divided by 267 is 2.86, 2 for 1 divided by 84 is 2.86, and 1,120 divided by 392 is 2.86. So these three methods are consistent among each other to decide which project is best. Clearly, in this project, project B is the best alternative.